Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift, and we've come a bit of a ways. We've done constants of various sorts and an if statement, and finally the other day we started working on lambdas, so we're starting to get towards functions. And what we've done so far with this, so we have simple definitions like x equals 3, that's legit. We've got lambda expressions, so backslash n is lambda n, and the expression is n plus x in this case. And what that does is it builds. I called it function yesterday, and I mentioned the word closure a couple times. Really, it is closure, and I think we'll change that name shortly in the code. But you build a closure, which is it knows the variable for the lambda expression. It knows the expression inside, the n plus x in our case, and it also knows the environment. In particular, it needs to know the environment for what they call free variables. So in lambda n goes to n plus x, n is a bound variable. It's tied to the argument. X is a free variable. It's just kind of floating around. It's defined in some sort of outside environment. And when we define this thing, we want to capture that outside environment and use that for the definition of x. It matters more when you start nesting things more than this. But you could have x in several layers or something like that, or imagine functions that called functions, and maybe everybody uses n for a parameter. Very old school, I guess. But then we would have to know which one are we getting. So we have this closure, and it bundles these things together: the lambda expression or the pieces of it, and the environment of at least the free variables. Okay. Now we want to evaluate it. We haven't done this part yet. So we imagine a function call. I put parentheses around my lambda expression so there's no confusion there, but lambda n goes to n plus x, called with 2. Now, if x is 3 and we call this with 2, we expect 5 for the value. So what's going to happen to evaluate it is we take the closure, just like on the left, and we take the argument, the 2, and we're going to feed that in to evaluate the closure with the argument. Well, it's going to create a new environment where the n gets tied to 2 and the old environment, and the rest of it points to the old environment. So just like yesterday, we added a capability in the symbol table to say, here's a set of variables, and if you don't find them in here, go look in here, and if you don't find them there, go look in there. Just kind of chain of responsibility kind of thinking, that eventually somebody will have it, or else nobody will, and then we know it's an error. So we're making a sort of 2 environment case here. X equals 3 is the outer environment. N equals 2 is the environment when you substitute 2 in for the argument. And so we have the expression on the left and this new environment, and you evaluate that, and we'll say, what's n? Oh, n is 2. What's x? X is 3. Add them together. 2 plus 3 is 5, and we get our final answer, 5. This is kind of, it's like, what does it mean to call a function? We're down there to the roots of like, what's the semantics of programming languages? This is really kind of very core to that, and it took a long time to kind of work this stuff out. Really, I did look up the word closure this morning, and I think there was an environment called SECD, SECD, and or maybe an evaluation model, SECD, for functional languages, Lisp in particular, or Lisp inspired. And Peter Landon, who's a big programming language person, defined this notion, and I think he may have pulled the word closure in, or he used it. Maybe he wasn't the first to define it that way. But in the original Lisp, they didn't do things this way. And so if you compare Scheme to Lisp, one of the things Scheme brought to it was saying, let's do closures based on the nesting level lexically, like textually. If you're nested inside this environment, you should reference the outer environment. I worked in Pascal way back when, and they had a similar kind of thing. So in in C, another old language, but in C you have basically global variables and local variables in your functions, but you don't have functions that contain functions that contain functions. Whereas Pascal did have that. You could define these things in nested layers, but when you want to access something, you don't want to go to the most recent thing. It's like you're not trying to get the latest definition. You're trying to get the one that's wrapped outside you. So if another function called you with referencing x, defining x, you don't want to get the x that function did. You want the x that is in the surrounding text. Okay. And a closure is a mechanism to do that. It says capture the environment and then extend it to evaluate things. And it really is a nice insight. The other word that's out there is func, and that's a programming technique that's sort of like it got introduced for implementing Algol 60, so I assume it's in the very, very early 60s. And they had the notion, we often see call by value, where you just evaluate something and pass in the value, which is Elm's good at. You also have call by reference. So if you pass an ampersand in a lot of programming languages, C and Swift and C sharp, and I don't know what Java does, but you can get to the actual pointers, and pass by reference. And so it's sort of a way to pass things in that can be changed, whereas by value cannot. There used to be another one called pass by name, and that was more like textually copying in the stuff you were using, the argument. So in that one, I would take the to, and I would literally just paste it in instead of the n, and go from there. But to evaluate those arguments, they had this little thing called a func that would kind of take care of the evaluation for you. You could pass this pointer to a function around, and it would evaluate arguments or provide them. They would cache them at some point too. But it's a very similar or related mechanism. But I think closure describes much more what's really going on in Elm and many, if not most, modern languages, I guess. All right. So we're in the middle of something, so we'll finish that, and then we'll accommodate this. So we said if you evaluate a lambda expression just as a standalone entity, we're going to create a quote function. And this word function, capital F, that really is a closure. And we will change that shortly. Let's get the test passing, and then we'll do that. So we implemented equality test, but we didn't implement an as string, which is useful for debugging and things like that. So I don't know if we're using it for anything. We might be using it for the kind of concrete leaf classes like integer and float and custom value. Not quite a concrete leaf, but the ones that we evaluate to and they print their name, they might use that as string as a production method. The rest of the things that are more nodes, it's more of a debugging thing, I guess. All right, so expression.print is not equal to function symbol table lambda foo, which is what we expected. And the reason is we don't override the method. So let's go in function. There is no as string. So let's find expression. Here's as string. There's that question mark expression.print. Okay. So we'll override that. Thanks. Okay. And what are we going to return? Well, let's steal it from this. All right. I'm making the executive decision. I'm not going to print out the value of the contents of the full symbol table at this point. We may. Okay, I'm gonna change this right now. Lambda, sorry, closure and closure. All right. Now bracket symbol table, that's just my default print for that. And then this, well, we have a lambda expression and we know how to get the string of it. Okay, so it's this. And we'll say lambda dot as string. Have I got my brackets correct? Nope, one more. My braces. Yeah, okay. Let's try that. I think we should be okay. But the little two-step dance we did in the picture, that's really what we're doing here. We're wrapping up the lambda with the environment. So you can see symbol table and lambda. We could have broken out those variables separately or not. That's okay. But we've got both those pieces together, and both those together is enough to evaluate a function. The lambda expression by itself isn't, because you might have free variables that you need to get from somewhere. All right, well, that's good. So we added function to hold value of a lambda. Right. All right, and let's rename this thing. Like, we got some insight, so let's take advantage of it. So I'm going to call it closure. Can I edit there? Yeah, okay. And rename. Let me just check my recording. Okay, yes, it appears we are recording. Good. All right. Okay, so there's closure. I don't see any other references to function in here, so that's good. And let's find the lambda. Okay, he returned closure. That's good. Nobody's using function as a name of things or anything like that. All right, let's run tests. Oh, function itself didn't rename. Okay, so function, the file renamed, but the test did not. Rename this to closure tests. Cool. Didn't notice it worked that way before. You can just click on it. I don't know what the not is, but maybe you can't rename it anything else. Okay, and here we've just called it expression. That's fine. Closure. Yeah. Okay, so we'll commit that. And I sometimes tag these when I think about it. Let's see. I suppose I should be telling you about stuff that I do other than this. So yesterday I put out a new article on TDDs, test-driven development. I use it pretty consistently here. But anyway, if you go to xp123.com, and the most recent post is balancing progress with stability, or TDD, balancing progress with stability. I think I've got a good basis for saying how I think of TDD, and it seems to have resonated well with people. So the real thing is we start with something stable, and then we have these moves that either improve stability or make progress, or they're neutral. And we also have negative moves, but I'm not going to put those in my picture. But we're doing refactoring here. We're improving the design. We had an insight about what's a better name. Oh, closure's the name we use for a function wrapped up with an environment. Okay, let's talk about closure. And so we renamed that. But other times, we might do preparatory refactoring. So we do some refactoring in advance with the design we anticipate we need. And we start to do the normal red plus green and some other moves. But anyway, if this sort of thing appeals to you, I hope you enjoy it. Thanks. Okay. Let's see. So here we are. We've got closure. We've basically evaluated our Lambda expressions. And I think we can... let's see. We left off with a test on here. Yeah. Test evaluate. And let's see if this passes now. We deferred it to get to other stuff. Okay, so Lambda expression. Oh, there it is. Okay, yeah, all the stuff we did. So we created a Lambda expression. Name goes to 42. Doesn't even use any variables. Okay, it's just it ignores your argument and gives you 42. We started off with a symbol table with y in it. And we said we want to make a closure with the symbol table and the lambda. I don't know if that order appeals to me perfectly, but we've got that. And then if you evaluate the lambda for a given symbol table, we should get the expected closure back. Okay. And with the work we did, we basically adding the equality test let us make this test pass. Okay, so evaluating and it was commented out. It was read. We commented out or blocked it with the X. But anyway, evaluating a lambda yields a closure. Okay, that sounds so good. I mean, it's calling functions is a really good thing for a functional language to be able to do, I would say. Okay. Next. Okay, let's get the to-do updated since I'm so bad at that. Okay, this is closure expression. Test for equality, test for string. Today's the 18th. And that's this. Okay. And we also interpret lambda expressions. We do that. I mean, I know it feels like we're just kind of pushing it off because we don't actually evaluate them with arguments. That's a different thing. It's a function call. Well, that may be the next thing to do. Okay, I do have a couple things I want to do housekeeping. One's internal to the system. Our error messages, when you make lexical errors like a weird character in your file or something, we tell you, oh, in line 7, column 3, you messed up. When you make other kinds of errors, either semantic ones like an if statement takes a Boolean for a condition, or parsing kind of errors. I did lambda goes to x plus n, but I forgot to put the n in there. Okay. Those errors at the parsing level, we just say, error, you had an error. And, it's not as helpful as you might like. So I would like to do that. The other one is, I mentioned the other day, because we had John Reed on as a viewer, and, it was on my list to get his latest template of test definitions, and he has other definitions in there too. And, I had to say, oh, I didn't do it, John, sorry. So maybe we'll do that too. But I think we may save that. I may do the latter one in the background, in the off time. But what I want to do, so up till now, let's find Elm-Lang. All right, and then the docs. We should see the syntax. Okay, so what I've done so far is cherry pick the stuff I like that feels like it's in the range of what we want to do. So comments, yes, we have both kinds of comments. Literals, we have these first few. We don't do strings and characters yet. but I don't think they're hard. I just don't think they introduce that much. We don't do lists. We do conditionals with if. We don't do cases. We haven't done records. We started looking at this though, and notice this function definition: square of n equals n squared. There's no lambda involved. This one does. So if I define square to take a lambda, that's the equivalent of this. And the equivalent to this sense that you could literally just kind of define a syntactic transformation that says, if it's a function definition, take the first argument, make a lambda out of it, put an arrow, put the expression that they had, straightforward. I know you can do the same kind of thing for multiple arguments, and you kind of need to in Elm because it supports currying, which means call the function with only some of its arguments. And the result is a closure, basically, I guess. All right. So we haven't done operators. We haven't done lets. We haven't done applying functions, and I think that's what I want to do. I don't want to do everything about it, but we've got enough information to do it. Here's custom types. We use Boolean as a custom type. We don't actually support defining it yet. Okay, but I'm sneaking ahead. So now, a project like this, one way to break it down is to say, okay, let's do the lexical analysis. Let's find a way to parse all the tokens. There's an arrow token, there's an equals token, there's a plus, there's a times, there's brackets and commas and everything. Okay, we could do that, and then say, okay, now let's define a parser. A factor is an integer literal, a float literal, a custom value literal. It might be wrapped in parentheses. A term maybe includes a factor and an operator and a term or something. All the grammar rules, and then could go in and say, okay, produce nodes. Okay, let's define all the nodes. Here's closure, here's literal, here's integer literal, here's float literal. And then finally we could define the interpreter, like how do you evaluate an integer literal? It just returns itself. Okay, how do you evaluate plus? Well, take the left, take the right, add them up, create a new literal. Okay, and so you could slice it like that, sort of 4 major sections of the system, or layers, maybe call it layers. Put the lexer on the bottom, and then the parser, and then the nodes, and then the interpreter. What we've done instead of layer by layer is we've taken feature by feature. So I want to do integer literals. I'm going to define how to lex them, how to parse them, how to create a node, how to interpret it. And we've sliced it vertically in that sense, and I call that getting a slice of cake instead of a layer of a cake. And we do all 4 pieces and then move on to the next one, and do all 4 pieces and move on to the next one. And we just moved we finished the lambda one, and the result of a lambda evaluates to an expression, and that's fine. And evaluates to a closure. Sorry. But I want to do a different version of this now. What I'd like to do is I would like to see function calling work for something. It needn't work for everything, because I know it won't. We don't support everything yet, but that thing I showed in the file here, I guess I gotta step in a little. Whoops. Let's go forward. There. Okay. We do the left side. We don't do the right side. So I'd like to do the function call and deal with that. I'm not going to deal with how do I parse it, or how do I lex it, or any of that stuff. I'm skipping up to, let's define a function call node and an evaluate method on it that applies the function to the arguments with the new environment and all the stuff. Okay. I think that's I think that's an interesting place to get something done. But when we finish, we won't have a whole feature of calling functions. We'll just have a feature that's if you create that node manually, you can call the function and see that it evaluates. I'm okay. All right. So let's do that. So our story is function call. Okay. And let's say, I don't know what you call this. It's not a spike because we're doing the real work, or at least as close as we can get for now. It's not a complete function, so it's weird. I need a name for this. I don't do it often. I mean I certainly have before. Just trying to pursue some idea, I guess. I somewhere I know I just ran across the piece of paper today. I was trying to get some things organized and now I can't find it, so it tells you something. But I was trying to like discipline spike or something, but it's not it's not a spike. It's intended to be real code. I had something else called something learning, some adjective on that. And whoops, sorry. I don't know. I'm not sure how to describe what we're doing. It's some people would just call it a task. We're doing a part of the thing, not the whole thing. We'll test it with a little funny setup, and we can't write code that does it yet. I don't know. Okay. But what we're proving it out. Okay, maybe I'll leave it with that for now. And so we want to, I guess the first thing will be a function call node and then evaluate. All right. And over here, interpreter, let's start with the test, I guess. We'll make a new file. Maybe just call. Is call good enough? I don't know. Let's do a function call for now. We can decide later. Let's rename that to function call tests. All right, and steal some boilerplate. All right, so let's make a function. Unfortunately, without operators, we're somewhat limited in our functions, but this test is going to function evaluates its argument. Okay, we'll see how we like it. Can I borrow from this? I think. I'll take these two. Okay, so I'm going to make a function an argument and it's going to return the variable it. So this is lambda it goes to it. And the symbol table, all right. And at some point I'm going to say, let's let expression equal, and we'll make a function call with, it needs a lambda and it needs a closure and an argument. Let's make the closure equals something. Whoops. Closure, and the argument is going to be integer value 17 with float elm type dot float. I guess number. Okay, so I don't have my setup and all that stuff, but I say function call with closure and an argument. And then the expected value, we say if you call evaluate with symbol table, we expect you to get integer value 17. Okay. I wish I had some operators to do this, but I'm still feeling good. Okay, so closure, we need a symbol table. That really is awkward up there, isn't it? Symbol table and a lambda. Okay. Now the symbol table doesn't have an it yet. We'll have to do that as part of our job. Okay. We don't have a function call, so let's go create that node. All right, and he's public class function call extends expression. All right, and we need an it which takes a closure and an argument of type expression, and we'll do nothing with it for now. We're just trying to get the test put together. Can't find function call. Okay, so this test should fail. Well, it should compile. What's going on? Oh, I'm not. Well, let's just say unknown for now. All right. All right, we got an error. Function called tests. And we see Whelm error expression is not equal to Whelm.integer value. Okay. We don't have an as string, so let's do like we did before. Maybe I should. This is I don't know. I don't want to call it preparatory refactoring. Maybe I just need to choose my first test a little better and say I'm taking too big a step. On these nodes, I should start with the as string, then do EQ, and then do the real thing. So let's do that. All right, so let's make a test. We're going to test as string. And unfortunately, I think we need a lot of this setup to get the pieces together. We need a lambda expression. We need a symbol table because that builds the closure, which we need, and the integer value in the function call. Okay. Oh boy. All right. So assert equal. If you say expr.as string, you should get function call. And then the closure, well, and this is, I kind of don't mind doing this a little backwards. I don't think it's, I don't know. It's lazy. That's what it is. But I know or I should say, I believe the closure as string works the way it is. And I believe the expression, let's see, the Elm type, the integer value, you know, the second expression there is going to work. Okay, so I would I'm going to be lazy and let it tell me what it gets and make sure it gets it right. The real thing my function call is adding is the parentheses around it and the comma. The two inside things, we know they print already, or they convert to strings. All right, so this will fail still because it's still printing the parent class as string. Expression provides a default. Okay, so we will need to override that. We can steal the definition here. I can probably steal the whole thing productively. Okay, function call. All right, and this is good. It pushes us to save our information. All right, this is function call, and it should be something and argument. This should be the closure. All right, and that sort of proves to us we need to save the closure. And the expression. Can I find argument? Have I left out a key path type from context? Extra argument in call. So I've done something silly. Oh. All right. Now I think this will get the right answer, but our test is wrong. I should have just run one test maybe. All right, see, we got we're getting there. Okay, so we say it's not equal to simple closure. I can just steal it from here. And I'll substitute this. Closure symbol table lambda it variable it 17 number. Okay, trying to make sure I don't have any weird lambdas in there that will throw it off. All right, but I'm willing to grant that is the way the closure should come in. And that the test should pass. Well, so much for that theory. Okay, function call, parenthesis closure, bracket symbol table, lambda, it, variable, it, 1, 2, 3, comma, 17, colon, number. Function call, parenthesis closure, function call, parenthesis closure, paren bracket symbol table bracket, yes, comma, space, lambda, it, comma, variable, it, 3 parentheses, 17, colon, number. Oh, I got a space. That assertion message could be better, couldn't it? I got used to NUnit or JUnit popping it up and showing you exactly where it is. All right, but that's okay. Let's test equality now. And oh my goodness. All right. So this, you can see why it would be handy if I could just do lambda it returns it and get the stuff out of that. We'll worry about it later. Okay, so I'm certainly going to need a lambda expression. I need a symbol table. I need a closure, and I want to make an expression. So I'm going to pull this together here, and then kind of make this thing. I'm going to make the same thing. Okay. All right, an xt assert equal expr1a, expr1b. Okay, and then I need something that's not equal. And I got this still here. Let's put a different number in here. Yeah. We could test both values being different. I'm okay with this for now. Okay, we should get a failing test. All right, so whelm function call is not equal to whelm function call. It would be nice if that message used our as string, but I guess it doesn't know anything about it. All right, but anyway, they are different, even though they're supposed to be the same. It's on this line. These two are different, and they're supposed to be different. That's probably happy accident territory. But we have a failing test, so we're going to do a green test next. But it's break time, so let's take 2 minutes. We'll come back, make this test pass, and then move on to that evaluation and see if we can get that working. All right. Hey, welcome back. All right, so we are about to fix equality. And again, I'm just going to steal the implementation here and adjust it because I'm lazy. All right, string EQ. All right, so the other, if it is not a function call, and self.expression, argument. And I don't know if there's I'd like to think there was some way to make this thing just work, but I don't think it does. All right, and let's check. Good. All right, so let's add as string and EQ to function call. And now let's make this evaluate. Should still fail, but we should get a better message. Error expression. Okay. Error expression is when you call evaluate without defining one. You get that. This, I got to figure out this. It may be, I'm bouncing all over. The deal is expression is a class. And it is because it owns the type right now, that everybody's going to define some sort of type. But what that means is we can't have, well, they're all children. They have to have the, it's going to be defined. So evaluate is defined in Lambda expression, and function call is just the value is error expression. Whereas Elm type being type, that's new information unique to this class. But maybe we'd be better off. Well, maybe this question: would we be better off if this were a protocol being just function definitions, and then everybody had to commit to providing this stuff? That might be better, just to get inheritance out of it. It's given us something, but it's hurting us too. All right, so at any rate, we need to do an evaluation. That part's fair enough. Okay, I'll just take the whole method for now. All right, and function call and evaluation. Oof. There. Okay. Now we'll go back to PowerPoint or Keynote. Okay. So we have the closure. That's an argument. I mean, that comes into the function call object. We have the argument. We need to create a new environment. All right, so we got the symbol table x equals 3 from our closure, and we need to add in the n equals 2 to that to a new inner table, as we called it yesterday. All right, so we have a closure, right? Yes, an actual closure, and so we know what to ask from it. So we want to get the closure, let the outer table context, is that better? Outer context is going to be equal to the closure's symbol table. Okay. And that's already a symbol table. And we're going to make the inner context is equal to a new symbol table. Okay. Now outer context not used. Okay. We want to pass that in. So that's how we get our chain of responsibility. We'll look first in the inner context and then in the progressively outer contexts. Okay, so now we have a good symbol table. That's our environment. We need to add to our symbol table okay, the name, which comes from the closure, dot, what do we call it? Lambda self symbol table. Am I getting mixed up here? I am. Oh boy. I don't think you give this a closure, right? We're supposed to have given it. Let's see. Let me just move this way. We're supposed to have a function call is supposed to get a lambda expression. And the lambda expression has the closure. Oh boy. Okay, let's bail out a minute here. Let me comment this, and we'll just return error expression again. Okay, so if function call in my picture did not take a closure as an argument, it took a function. What did it take? Now I'm confusing myself even more. Okay, the closure. Well, is that right? Function call is going to take our function. Yeah, closure is what I called function yesterday. So it does take a closure. But a closure should know its name, right? We have closure up, yes. Okay. Symbol table. Oh, it knows it's got a lambda. Yeah. Jump to definition of lambda expression has the name. Okay. Right. So function call. This is not as bad as I thought. Okay. Panic. All right. So the outer context, the symbol table, that is fine. If we take the closure dot lambda dot name. Okay. And we have to define it. Oh, argument 2, yeah. Okay, and we want the argument. So we're saying n equals, we're saying our lambda name equals whatever argument you passed into the function. So the function call takes an argument. All right, that is fine. Okay, so now we have our environment. Now we want to evaluate something. Well, we want to evaluate closure dot lambda dot expression, and it needs a we want to evaluate that thing with a context. Well, we'll use inner context. The result of that, well, we're just going to return the result. It's an expression. Okay, so I know it's like in some ways it's complicated, and in some ways it's very simple, right? So we have our original symbol table coming from the closure. The closure wrapped up a symbol table to get those free variables. We create a new symbol table that says if you don't have a name, pull it out of the outer context, and then we add the function's argument name. Okay, so the closure has a lambda name. We add that name. N goes to something. Okay, our 2 in our example, right? I mean, we can't do plus, but if you take our example, okay, I'm going to get this better at that. N plus x, okay. I mean, if we just did n goes to n, you know, it needs to pass the 2 in with a value of n so we can evaluate it. And in our evaluation, let me pull up variable. How do you find the value of a variable? Well, you see if it's in the symbol table. And if it is, you use it, okay, and evaluate that symbol. So we get the value of the thing. Okay, I hope. If I've done all this right. Okay. So build the inner context, add the argument to it at its own new level, closure lambda, get the expression, evaluate it with our inner context. If we evaluate it with the outer context, it's not going to work because we don't have a definition for n. I mean, I hope this works. If it doesn't, there's something else wrong, but Um, Yay. Okay, my gosh, that's like it's like the most fundamental thing down in there. Like, what does a function call mean? And with everything we've got, it comes down to kind of like 4 lines here. Take the old symbol table, wrap up a new one with the argument, evaluate the expression with that argument. That's yeah, woohoo! That's that's what I want to see. It's pretty. Okay, now let's commit. Okay, make function call evaluate. I'll capitalize it for the class, even though it's not like static work. Okay. Create new context with variable as argument, then evaluate. All right. Now I want to refactor a little bit. The thing I don't like is I'm going this dot 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 stuff. 1 or 2, yeah, this is already off. I'm navigating my way through the closure to the lambda, and the lambda is going to have a name, and I don't want to rely on things 3 levels down. Now I don't mind in 38 if I do closure.something.evaluate. That seems okay. But what I'm thinking is the closure should know the name. So let's migrate that over here. Okay. So the name is always going to be a string for us. That maybe should have been subject to change, but it's as it is now. Okay, so we have a function name, and we want to return the lambda's name. Okay, and returns a string. And similarly, we want to have a function expression. Turns an expression, which is lambda.expression. Okay, so I'm saying those things can be there. Let me refactor them from closure. Nope. From function call. So I'm saying, how about you just ask the closure for the name? Maybe that should be that, and this should be that. We can make them variables. Our name computed variables is just as good from my perspective. All right, so lambda, function call. Okay. Evaluate, get the closure name, get the closure expression. Yeah, this way I'm only asking for the direct level, and closure knows I've got to get that from the lambda. And I may have just like here, I made my closure in my explanation, I put it in 3 boxes instead of 2. And that's a decision I made. We could make a different decision, and then we wouldn't have to change the callers at all. If we'd broken it apart when we put it in the closure and then just fetch the fields. All right, this should work. So let's see. I guess we kind of did a one-step thing, but it's a refactoring. We introduced name and expression method. Well, they weren't methods, were they? Name and expression computed fields on closure. Use them in function call. Right. Okay. To do should be updated. Yeah. Story is function call, prove it out. Okay, so I'll add a note here. This gives us a one argument function built from a lambda. All right, and we still need to parse it, unfortunately. I say unfortunately because I know the grammar is a little ugly. Okay. Let's add the rest of function call. We'll keep that on our little stack up here. Okay, so parse function calls. Okay. And decide how to handle multi-argument functions. Okay. My guess and understanding is something with 3 arguments turns into 3 deep nested lambda expressions. And if we do that, then I think the currying that we talked about and all that comes free. Okay, wow. It's such a good moment. I guess I want to bask in it a little bit. Pop some champagne or something. Okay. Let's just do a task. And we'll upgrade our test. I don't know what we call these, prototypes or something. Let's see how this Q coding one works. You know, it may be something. Oops. If we don't like it, we'll drop it. That's okay. But put this back, and I'll save and minimize that. Okay, save and quit that. Where is? Oh, I just minimized it. Okay. Q coding. He's not CA. Wow, I would not have thought his name would get overtaken here. Is it just .com? No. Oh, wow. I know I saved his message somewhere too. This is it. No, nice, but well, I know he posted this in the last few days. Coding. Device recording. Yeah, he's on Twitch too. I haven't caught it very often, but once in a great while. There we go. Hopefully there's a README. I installed his old version. Okay, we need the Swift ones. Installation. Access this folder from the terminal and type make install. Okay. We have a terminal here. Let's first. That's not the way to do it. XC test. Access that folder. Okay, so I guess I'll just. Seems odd that I would go install the XC test suite templates. Access this folder from terminal. I guess I get the whole thing, so I go up a level. Where the make file is? Little clue. Oh, was I supposed to close Xcode? Well, I have to. It's part of the project. Okay. And we'll open it again. Create a new file from Xcode template. Oh, app code. I think he's just typing the word test to get that. Let's put this on window 1. I know I can pin it there. I probably should. I spent enough time moving this thing around. All right. What do I do? Well, okay, I can go in there, which is over here, I think. No. Was it committed Elm? This thing? I am not sure what that is. Oh, maybe it's a template when I create a new one. All right, let's just create a new class just to see it do something. New files. There we are, Swift XC Test Suite. Okay. Yeah, so he likes to talk about test 0, just sort of a guaranteed failing test. So if we run it, this should fail. But notice he does I thought he took my name into account somehow. He does do this. Let me we're building. Okay. Oh, I guess we're doing a first time build now. I'm going to create another one and just call it my and see what happens, or call it junk. What I don't know in Xcode, if anybody listening knows, please tell me, but can I tie a keystroke in that just is like Control RT that says build a test case, that automatically says new file with test case, XC test case. Okay, so this test not implemented, yes. All right. And yep, that's there. Let's delete this guy. We'll create another one. Yeah, I'd like a keystroke that did new file, Swift XC Test Suite, next. Pop up some sort of dialog for me, and I type junk. I think it's just call it junk. Yeah. Okay. So I have to call it something tests. I don't really care about the final. Okay. I almost, it's pretty rare that I extend a test case, but I guess it keeps me from doing it accidentally. All right. And notice it does pick up my testable import, which is nice because that's an easy line to forget, and XC test, so we get XCT fail and so on. Yeah, that's pretty straightforward. All right, let's just delete that. All right, John, if you see this, thanks. A little bit of progress. Well, while we're worrying about this stuff, let's see what this is. I guess you get everything I'm doing on this project, even the junk extensions. So I can download some extensions, huh? Format. I don't know what a lot of these are. Well, I can see it would be nice to have some stuff. I wonder what switch it does. Xcode line sorter. I don't think I can see myself using that. Okay, but it's nice to know they exist. How about preferences? Oh, behaviors. Maybe that was the one. No. Well, I got key bindings, but I don't think I can do anything to get those in. All right. It'll be a question for another day. All right. Let's see. So I think Q coding, qualitycoding.org. How about install package from qualitycoding.org? Okay. Okay, nice. All right. What we're going to do next then is we're going to tackle this error message thing, get that right. And I think after that, we've done nothing to speak of on the UI side. So show REPL, maybe it's even provide REPL in UI. That's a little weak for a story name, but I'm getting ready for a break, so I'm rushing myself. But what we have right now, the user interface is not the interface we want. Okay, so it's just a dummy hello world. So we created it, the Swift UI, and we need to put at least a little REPL box and maybe some scroll bars or something. So let's take a break, 3 minutes at most, and come back and tackle error numbers, the line numbers of errors. And see you in a bit. Welcome back. All right, so we are going to do some error message handling. This is kind of another case of that, I don't know, the discipline learning or the discipline spike or whatever I'm going to call this thing, but this process that we have things that are most valuable to us from a learning perspective about what our system needs to do or needs to be. And so we push on those, even though our system is not expanding kind of gracefully. It's lumping out in different corners. Juan Carlos Beco, howdy. Nice to see you here. Normally my TDD, I try and grow microfeature by microfeature and just kind of this nice expanding system. When we're doing what we're doing here, we grow some parts like that, but then there's a lump over here like, oh, no error messages. Ugh. Function call evaluation, but no actual syntax for it, So it gets these lumps on it because I'm pursuing things opportunistically to my learning, not systematically to say, okay, here's the next complete version of the system. Let's see. So yeah, we are on Mac. We're writing code in Swift, and we're trying to write an Elm interpreter. So we're going to give Elm input. Let's see. We've got some here somewhere. Elm syntax. So we're working through this Elm syntax, trying to handle various things like function definitions and so on. What we got so far is we do comments, so you can dash single line or brace dash brace, nested comments. We do booleans, numbers, and floats, but not characters yet. We don't have operators, boohoo. We don't have lists. We do have conditional if, and we have the seeds of functions right now. So on the side over here, we're just going to go into it. The parser is basically a recursive descent parser. So it gets a little crazy, but basically recursive descent, in Swift, recursive descent, you sort of set the first token ready to go, and every time you parse something, you make sure you leave the next token ready. So the front end of the parse is, look at the current token, if it's into file, or is it a lambda or an int or whatever, okay? Not into Swift. So what language are you working with on there, or shell or some other language? I guess you could do Java or something too, right? I don't know. Well, Swift's similar enough to Java or C# or one of those to kind of make your way through it. There are definitely differences, and the UI stuff, the user interface is way different, but we're not touching that today. So at any rate, every grammar rule turns into a function call, and every literal token turns into a get. Okay, cool. I'm not familiar with Nim. There's so many languages you want to learn about, There's just so much time. And especially if I take a pretty good sized project like this one. Let's see. So yeah, you can either consume tokens one at a time, or you call a function that represents the whole grammar rule. And what we have going on, let me go into the lexer. The lexer is sort of like regular expressions, kind of that level. And, like here it's looking for dash followed by greater than. Oh, that's an arrow. Dash followed by dash is a comment. Okay. Otherwise, right now we don't handle anything else. Okay. But you can see here token.error has an error message. If you go back to parser, you make a mistake here. Empty expression's okay, but here's error expression, no messages. And so you don't know, you just know like, hey, the Lambda expression failed. We don't even tell you where. Now these things, I thought we added locations on the tokenizers. Maybe I'm misremembering that. Okay, the error has the location. Yeah, so that says we'd like our parser errors to have messages, but we'd also like them to have locations. So I can tell you, not just your Lambda expression was bad, but in line 3, column 4, your Lambda expression was bad. That'd be nice. So what I'm gonna do. Right. So I think the first thing we'll break this into two parts. One is let's get some messages on these things. So error expression should come back with a message. So at least you could imagine getting an error message that says your Lambda isn't right. I don't know what you didn't have a variable name for your Lambda. Okay, is what this one is. And this one is you messed up your arrow token, I guess. So I think if we get the error messages in, and then we'll worry about location. So let me put that in my little stack of things to do. Provide error messages, provide error locations for parsing errors. And if I wanted to say a story, this is, error messages. Okay. My stories are a little technical, but we're writing to people who know compiler or use compilers. So, all right. So presumably I've got a test somewhere that tests this line of code. Let's find it. Where's Parser Tests? All right, let me see if I don't know if splitting it will work very well, but pretty minimal. Okay, check successful parse, check failed parse. Here, check failed parse. Okay, unknown custom value. Okay, so that's the input. Maybe we should have an error message on this. So I'm going to add an error message in our test. Unknown custom value. I assume that's the error. And then message, we'll make this optional. Message of string optional equals so equals, let's just put a question marks. Looks a bit like Golang. Swift, they're all kind of from similar roots, and Golang is from the old time Unix people, so it's got a lot of C in it. And Swift, it kind of grew forward from Objective-C, C#, maybe some influence, Java, Smalltalk, C++, maybe to tell you things you don't want to do in some cases. But, there's definitely a lot of similarities. And then, you don't have the objects in C, but you've got sort of object-ish things in Go. And the enums are probably more similar to the Go stuff too in some ways, but Let's see. So doing this, I add the message, I make it an optional parameter, and I give it a default value. Anybody else who calls check failed parse is not going to have that problem. They don't have to have a message yet. So this is a way I can do kind of stepwise changes. Just get one thing working, and go from there. Now everything should still work because I don't look at this message string yet. Okay. Now I would like, let's go to error expression. Okay. It defaults to this string error. Now I would like to have an error message here too. So I'm going to do the same trick. If I can type. Message of type string optional equals something. All right. And I'm going to call it unknown error message. So that's probably a good string for my other default as well. Okay. Now my parser test. And do I have an equality on that? I do. We can improve that. Okay, so I've got failed parse. It looks for a message. I guess if I want them to default to the same thing, that's probably okay. I don't know. Let's do that for now. Okay, so I'm going to get error expression. Let's say expected equals error expression of message. And I think that is okay. Whoops. Expected. Okay. Argument passed to call it takes none. Well, it's just not caught up. Should all pass. All right. Because EQ only says, it says all error expressions are equal. Okay, I want to change that. I don't know if we made a test for error expressions explicitly. It doesn't look like it. We've let them grow just from the usage, but let's say we had something similar in structure here. EQ. Okay, so we'll do this. Let other equals other as expression. No, there's a way to do this. Oh, I don't want to say all errors are equal. I want to be equal if they have the same error message. Okay, so I guess where it started out is okay. Let's do that. Other equals other as error expression. Okay, and if self.message not equal other.message, well, maybe it's the other way around. Maybe I can just say return self.message equals other message, and then I have to save the message. Message of type string, and then in here I'm required to fill it in. Self.message equals message. I guess we know it always has a value because we gave it one. If somebody passed in nil, we just won't let people do that. Okay, if the other thing is an expression, return the messages are equal, so the types are equal and the messages are equal, and then otherwise we just return false. All right, this should still pass. Oh no. Oh, this is okay. This is actually good. This line, I'll just comment it for a moment. Where we started the day was like this, just checking unknown. This string unknown as an input should fail because we don't have a defined type for it. All right, and this should all pass now. All right, we'll push this. So error messages are equal only if error expressions, if they have the same message. Okay, that's our innovation here. But under the context of our tests, it's all fine. Okay, but now I'm gonna step forward, and now we've done enough infrastructure. We're gonna make this thing work. So we know this test fails, unknown custom value, and we know parser is where we're gonna look. How about, I don't understand this IDE sometimes. Okay, where's parser? Okay. We had unknown value. So token dot uppercase name. We went an expression, and yeah, here we get an uppercase expression. We find the name. We look it up, and if it's an error, then we want to say this is an unknown custom value. I think this should pass. All right, so Parser Tests. Now what I'm we're getting some duplication, right? I've got two things that know unknown custom value. Ah, boy. And those are going to have to be internationalized at some point, right? What could we do? We could put constants on error expression. We could define a new enum. Let's do that. Enum error. Can it fill it in for me? Error message. Now, can I define them? I don't know if I'm doing this the approved way. Okay, that seems like it's not complaining. Cannot have a raw value if it does not have a raw type. Let's see what they're pretty sophisticated in Swift, so I don't know. There's probably a way to do something like this. You have your basic ones. You can just put a list of them, but you can you can also make functions on them or switches on them, iterate, associated value. That's what we're trying to do. I don't really want to. Yeah, I want raw values, so I just put the type in. Okay, well, let's do that. So I think I can say string. Yeah. Equals this. Okay, I guess I will alphabetize. Oh, I said 5 minutes ago, 10 minutes ago, I don't want to alphabetize. There you have it. All right. Let's use that here. Oh, come on. Yeah, you can have recursive enumerations, build your own trees. Okay. Let's just do this way. Static let okay. I guess this is an improvement. Unknown custom type. And then our tests will use the same thing. This one is error messages. What if we called it unknown error message? Okay. And this is error messages dot unknown custom value. Oh no. Unknown custom value. Unknown custom type. Oh, it should be value actually. Probably lowercase unknown custom value. Unknown custom value. Okay. All right, and my intent is once we get these error messages in place, we will add messages every time, and I'll take off that default one. Add error messages class with strings for each message. Okay. I don't know which direction to come from on this, but let's just find these error expressions as they go. So here's parse had unexpected token. We can I'm sure we can get a better message, but I don't know if anybody's checking this. Okay. Unexpected token. I think that's human talk. I think it'll be easier to go in this direction. If we find one that tests it and doesn't like the message we gave, we can always put another better message in. All right, so error expression, we got that one. All right, now this one, the problem is no parameter. What do we call the thing in the Lambda expression? Let's hit Wikipedia. Really, Wikipedia is not even on the front page here. There we go. Formal system. This is kind of this. I'm thinking parameter, but we'll see. Variable. Yeah. Okay, variable's fine. This is missing variable in Lambda expression. And unfortunately, the flow is a little weird. You know, this try brings you out to this error expression here. Missing arrow in Lambda expression. Yeah, it would be nice if somebody had checked that one. Now this one, the tries, it's either missing then or else. Oh, parse error. All right. Without a then fails, that's... Okay. This one... Well, I guess our error expression could be a little better now. We don't need question mark errors. Let's just return the message. Or maybe error message. I think that'll help us. But what I'm seeing is there's multiple reasons to fail on the if and not just a missing if or then or else. Okay. Parser tests. Elm.error expression. Yeah, this thing doesn't know to call as string. But I think this is the same. But this one is not. Okay, so this case, yeah. Require is going to do something. What does it do? It throws a parse error. Right. This is a different error here. So this is complaining about the Boolean. Let's break out that case then. All right. So, well, all right. It looks like we're at our time limit. So, we need to handle different kinds of errors coming through. So, this one, they're all throwing parse error, but this really has something else going on. The condition is not a Boolean type, and that's the problem. So we'll pick up here next time. I'll leave it with some red tests, and we'll know we got to work on those. So let's see. Yeah. All right. Thanks for joining me. Next time is Tuesday, 1 to 3 p.m. Eastern time. Basically, that's my steady schedule. Well, so Tuesday, yeah. Thanks for joining me again today, Code Wrangler. We'll pick up there Tuesday. We'll get these syntax errors in and then get some locations in and make this thing into a real REPL. We can type something and get our 42 colon integer value back or something. All right. Thanks for joining me. Take care. Bye-bye.